Alright, there is another problem of linear algebra from the Nbhm exam 2023, and the question says that let A be a real n cross n matrix. Okay, we have real n cross n matrix which satisfy this. Okay, where I knows the n cross n identity matrix. Suppose that A has no real eigenvalues. There is no real eigenvalues. Specify all values that n could possibly take. Okay, first of all, we are given that a to the power 10 is equal to I. This means the polynomial px is equal to x to the power 10 minus 1 is an annihilating polynomial for A. It satisfies all the polynomials which are satisfied by the matrix are called annihilating polynomials. Alright. So we know a result that we are going to use a result that if mx mx is minimal polynomial, for A, okay, mx is for A and say px is an annihilating polynomial of A, then mx must divides px. This is a result. Alright, so we are interested in finding the minimal polynomial of A. Okay, using this, first of all, we see that the x to the power 10 minus 1, or okay, let's write this a to the power 10 minus I. This can be factorized as, okay, let's take from in terms of x. Okay, we take in terms of x. In terms of x, we have x to the power 10 minus 1. We can write it as x minus 1 into x to the power 4 plus x cube plus x square plus x plus 1 into x plus 1 multiplied by x to the power 4 minus x cube plus x square minus x plus 1. This is the factorization of x to the power 10 minus 1. You can do the calculation yourself, not big deal. Alright, so what are we are interested in, since we are given that there is no real eigenvalues. Okay, so I am claiming that minimal polynomial cannot have this factor. The minimal polynomial must not have this factor. Not possible. Also, this factor is not possible because in both the cases we have real eigenvalues. Minimal polynomial can have this factor and also can have this factor. Both of these polynomials are irreducible. I can just give you a hint why they are irreducible. So first, let me complete first that these two are irreducible polynomials, so they don't have any roots, any real roots. Okay. So as we know that roots of minimal polynomial are the eigenvalues. So we cannot have these factors in the minimal polynomial. Okay, let me repeat it. We have shown that the minimal polynomial divides the analytic polynomial. So the minimal polynomial of A will divide this And these are the four possible factors of x to the power 10 minus 1. So now the question arises, what can be the minimal polynomial? Minimal polynomial can have these factors. Only these are the only possibilities. But I am claiming that it cannot have this, it cannot have this. Only these two are possible because they are irreducible. We can observe that this is a cyclotomic polynomial. Cyclotomic polynomials, and these are always irreducible. And this polynomial, we can see that this is come from this polynomial by p minus x. And if px is irreducible, then so is p minus x is also irreducible. Therefore, both are irreducible polynomials and they can have only complex roots. So the minimal polynomial, what I'm claiming is that now the minimal polynomial for a mx, okay, I should mention it. The minimal polynomial for a can only have factors q plus x square plus x plus 1 or x over 4 minus x cube plus x square minus x plus 1. And we also know the characteristic polynomial is also the characteristic polynomial is also a multiple of minimal polynomial because minimal polynomial divides every analytic polynomial. So the only possibilities of characteristic polynomial is either its power of this, or their product. So in each case, the characteristic polynomial will have, you can see that the degree of characteristic polynomial will be 4n. We can observe this form. If we take power n here, power some m here, it will always come in a factor of 4, where n is greater than equal to 1. This is the solution, this is the answer.